guys, I'm Steve Trudeau, the owner of Tru Design Build. We're here in Quincy, Mass. Beautiful spot. We're building a new custom single-family home. We've wrapped the whole exterior of this house with continuous insulation. We're using Rockwool Comfort Board. I have with me today Nick Stone from Rockwool. So we've sheathed the house with zip system, also with just half-inch pressure treated. We are in a flood zone. We can talk about that a little bit more. But we did use your Comfort Board 80, the 1.5" product. We tacked it in with these 2-inch cap nails at first to get it going, and then we came back with this 1x3 strapping. This also gives us a nice rain screen. If you want to tell us kind of about the properties of Rockwool, that would be great.
Yeah, absolutely. So this is out here on the outside. This is our Comfort Board 80. We have both Comfort Board 80 and Comfort Board 110. What's really nice about having this on the outside is you're going to have your water resistant capabilities. So when we make our products, it's made with an oil-based binder. So think about how when you're at home cooking, how oil and water, how they repel away from one another. So that way, even though we're out here in the exposure, we have the water kind of over here to the left of us. When it rains, it's going to actually kind of hit the product, beat up and roll off of it, sheds that water very nicely. But this is also going to go a long way from a condensation factor. So one of the beauties by adding the exterior insulation to the outside of our buildings is we're going to move our condensation point from the cavity, which is full of wood, right, from the framing to the sheathing. It's going to move it out to the outside of our WRB, out here into the insulation. So it's going to, when it condenses, it will drain right out the bottom, keeping that system nice and dry and durable.
Right.
So one of the fantastic properties is that water resistant capabilities. I always like to tell everyone it's like having a soda can. Right? If I give you an ice cold soda in the middle of the summer, right, it gets wet on the outside from condensation. But if I put a koozie, so think of the insulation as a koozie, that koozie is going to keep that dry. What we're really doing is we're keeping the vapor molecules vapor with inside the cavity. Right. And then with the air, as it gets colder, cold air holds less vapor molecules than warm air. So what happens is as it gets cold, it's out here in the sheathing. So at that point, that's when it starts to condense and it's out here draining through the system and boom, keeping it nice and dry.
Yeah, so we have about almost 3/4 of an air gap here. So our lap siding will go on this. We'll have maintain this channel. We'll probably use a core vent on the bottom to prevent any bugs, but it'll allow that air to ride up through here, and then we'll have a vent at the top. But a great system. This is an R6, so we've put a continuous jacket on the house.
Why don't you tell me a little bit about your corner, because I really like this detail quite a bit.
Yeah, so me and my siding crew were talking about how we handle our corners. So this is a kind of funky corner. It's about 120 degrees. You know, normally we have a 90-degree corner, but when we put our trim on and our siding, we need a good place to land the lap siding to nail it. So this gives us a nice wide surface in plane with the trim to keep everything nice and straight. But it worked out well here. The other detail that we had to figure out is bucking out the windows, which we can kind of go around to the side and take a look, but we had to buck out the windows. So our windows kind of sat in plane.
So you did an Audi window, pulled that window out, bucked, framed around that opening.
Correct.
Sealed back to your zip system.
Correct.
And got a nice tight seal. That's awesome. You can even see it right over here, but that's not a window though. What is this thing here?
Yeah, so we're in a flood zone here. Flood zone is around 4 feet above grade. I can show you over there, we have a flood gate that will be installed inside this opening. But you know, in the event of a flood, that gate will open up, allow water into the building, but also to let water drain back out. From a engineering perspective, if we don't allow water in, this is really kind of acting like a dam, and a lot of pressure gets put on the wall, especially with the wave action. So allowing the water in equalizes that pressure between the wall. Why don't I show you one of those floodgates? We're using the Smart Vent. It's made out of stainless steel because, again, we are on the ocean. It has a little float system inside here, so normally, you know, raccoons or other animals can't just, you know, get inside the house. When the flood does come, it'll lift those floats inside, allowing the water to enter into the building. And then same thing when it's coming back out, it allows it to come back out. So it's kind of cool product. We need one of these for every like 250 square feet of the space on the inside. So I think we have about 6 of them on this project.
You know, it's also really nice, you know, being that you have the Rockwool on the outside and you're in that flood area. once this rock wool gets wet from the water tide rising, it will actually, when it comes back down, it's going to actually dry itself right back out.
Right.
That way you're not ruining the insulation. So realistically, this is the perfect setup.
All the framing on the inside of the house, if you duck under here, our temporary door, you can kind of see all the framing on the first floor here is all pressure treated lumber for the first 4 feet. So we had pressure treated plywood with 2x6 pressure treated studs for the whole first floor here. We took that approach because it's a little bit more cost effective than pouring concrete all the way up here. Regardless, we had to frame, a small wall above.
Yep.
So a little bit more cost to go to PT versus pouring an 8-foot concrete wall. Here we only had to pour a 4 feet concrete wall.
Absolutely. Now, what did you think about installing the rock wool? Kind of give me some feedback. Was it pretty easy to go up? Was it fast? Did you like using tap nails? Because there's some other different fastening methods as well we could use.
Yeah, I mean, this is our first time installing this product. Little research, I found that cap nails are probably the easiest and readily available.
Yep.
You don't need any special tools really. But it went up quick. You start at the bottom. This product is 2 feet by 4 feet. We staggered the joints all the way up. I think we used anywhere from 2 to 4 nails per sheet, tacked them up. It moved quick. My installer actually enjoyed using the product, and then went right over that with the 1x3 strapping.
What's nice about putting on the rock wool layer, it's just a temporary hold. All your holding power is going to come from the strapping here. So just getting it up, like you said, with enough cap nails just to have it kind of secured in place. You could have went like EPDM washers, a little bit wider washer. Say if you were going to leave it up for a longer period of time before you're putting that strapping on, just to give it a little bit more holding power. But because you came so quickly to put the strapping on, this is just a temporary hold. So that style fastener is perfect for that application.
Is there a duration that you can leave rock wool exposed for to the UV?
Yeah, so when it comes to being UV stable, rock wool does really great in this category. We can be exposed up to 1 year before being covered. Realistically, you want to get it covered as fast as possible, but we all know that sometimes on the construction site, things just happen and it slows down. So we're very very good on that UV side of it. Also, expansion contraction. So if you kind of take a look over here at this wall, one of the big things that we don't traditionally talk about when it comes to insulation is expansion and contraction of material. Because we think about it, we've always been in cavities, right? In cavities, you're 16 or 24 inches on center. You don't have much movement in that. But when you start to get long runs like that, expansion contraction actually starts to play a big role.
Right.
So rock wool moves 1/10 of an inch over 33 feet compared to your foam products that can move up to 2.4 inches over that same 33 feet.
It's very stable.
Very stable. So what that really means for us on the job site is if you had a 4x8 panel, you could see a 1/4 inch or 1/8 of an inch gap around all 4 sides, and that's going to be wearing and moving on that WRB behind it.
Especially when you install it. So if I were to install foam on a hot day, it's fully expanded.
Correct.
And then when the winter comes, we're gapping it and we've kind of compromised the system in a way.
Absolutely.
One thing I also really like to do is all our electrical boxes we can actually bring to the outside of our WRB. So we actually, we're able to put this electrical box in the cavity. We can seal back to our WRB with some fluid flash, and it gives us the ability to kind of not have to cut into the sheathing and compromise the sheathing.
I actually really like these boxes because if you didn't, say this box was right here in the middle, you would have to buck that whole area out if you didn't have this box independently of itself. So that's a really nice add. I actually haven't seen that yet on a job site, so that's very cool. Now on to my favorite part, windows. Should we?
Yeah, let's talk about it.
All right.
We might have to go up on the deck here because most of our windows are up on the second level. So Nick, kind of you were talking about detailing your windows and doors, kind of handled the same way. So we bucked our doors and windows out with 2x material. We're 1.5 inch rock wool with the almost 3/4 inch strapping. So we bucked these out just over 2 1/8 inch, I believe, was our total buck here to kind of keep this all in plane.
And you know, one of the big things that I'm kind of seeing right here is we're taking our from an air control standpoint, we're going from the door itself, you know, on the face, down the sides, and then back onto the sheathing. So making those you know, three-sided connection, if you will, is super critical when you do what I call a three-dimensional wall, or in other words, we're pulling that wall out.
Right.
So we have shelves up at the top of the windows and doors. So getting that, you know, that seal is one of the most important things. You guys have done a fantastic job wrapping all the way back to the sheathing.
Yeah, we made sure, especially at the heads of the windows, you know, where most likely, you know, they would leak, to, you know, really make sure we detail that well. We used, you know, Zip's regular tape and their stretch tape, made sure it was rolled well. You know, obviously we used a sealant behind the door flanges, but it worked out really well. And, you know, now we can apply our trim here, which then leaves us enough space to install our lap siding as well.
When it comes to sound protection too, being close to the road, you know, I don't know if how bad the weather from a sound perspective gets, but having this nice wrap around the outside with this insulation is going to boost the performance of that acoustically as well. So you're getting kind of double bang for your buck there with thermal and sound protection. They're going to love it.
Yeah, it gets very windy down here, so hopefully this will be a super quiet home.
Yep.
Thanks, Nick. Appreciate you coming up. Thank you.
Appreciate it.